Okay, let's get started and then I'll start recording.
Recording in progress.
Alright, hello everyone. So today we'll talk about your written test number 2. The guide has been posted, and then I also updated the slides you have to study up to. I believe it's slide 69, but correct me if I'm wrong. But anyway, it's on the guide, so you can take a look. And I just look at the practice question which I made available on the e-class. I think so far not many of your classmates have got a chance to try them out, but you can still try them out until Wednesday morning. I would suggest maybe we can start a Q&A session with maybe any of your questions related to the lecture. We can do that first to clarify any aspect you want me to clarify about the bridge controller. And then if time permits, then we can maybe go over some practice question if you want to. But I think it's important for you to try first before you clarify. I still got my office hour tomorrow over Zoom and also Tuesday in person. So you can still ask me to clarify the practice question if you want to. But today, I think we may want to prioritize the lecture questions if you have. Alright, I'll just take your questions. You can type on the chat or you can speak up anyway. Yeah, any parts for the bridge controller, if you want me to explain again, that's fine. Or any parts.
Sir, first, can I ask a question?
Of course.
In one of the classes slides, I believe it was like the title was "Guards of Old Events."
Sure.
First refinement.
Give me just one moment. Let me go to that slide and then we'll talk about it. Do you remember the slide number? Or I can just go there.
It was probably 52.
Okay, sure, around that range. No problem. Okay, let's go there. Okay, possibly not there yet. Can it be this one or later?
It might be this one.
What about it?
It's the part that we find the second guard that we have to add. And by that we use the abstract guard of the MO out and the linking abstract and concrete states.
Sorry, are you talking more about this sequence over here, the one at the bottom?
I believe so.
Okay, so which part? Sorry, which part do you have question about?
I think it's from your lecture slide.
Okay, sure. I mean the iPad notes or.
Exactly.
Okay, let me go there first. Give me one moment. Okay, if that's about guard strengthening, there should be. I'll switch. Give me just one moment. Okay, it should be around over here. Okay, it's after deadlock. Okay, it should be this one here. Okay, so let me just switch here. Okay, that's about deadlock freedom, and then okay.
That's this slide.
Oh, this one here, right?
Yeah.
Okay.
I didn't totally get how we got the second guard.
Oh, the second guard. Okay. Okay, you mean this one here? This one here, right? Okay, sure. So this one here is more about the limits. So if you go to the corresponding slides, I'll show you two things, and then I'll show you the equation that you will need to look at. So for that particular guard, if you look at, okay, let's see over here. Okay, that's invariant, and over here. Okay, so that's about ML out. So that's really over here. So the informal description would be the number of cars on both the bridge and the island should be limited to some extent. So here the limits should really be also consistent with, since we're talking about a refinement model right now, like M1. So whatever constraint you also put as a limit in M0, we should make sure it's also respected. So that's why. So when you try to derive this particular guard, I mean the second one here. So give the first guard that's just about the traffic flow to this way here must be 0. So we can go this way, right? That's ML out. So that one will be useful as well. So number one, you should want to refer to M0. So if you go back to M0 for ML out, the abstract version, they actually got this particular guard already. That one is to say the number of cards in the bridge and the island. Remember, in the M0, we don't really distinguish between the island and the bridge. It's more like a bridge-island compound. So in that particular compound, N should be strictly less than D. So we want to make sure whatever second guard we put over here should be consistent with this abstract guard. So that's why I put it as a first equation. So we put it here. And because that abstract guard has to do with the abstract variable. And whenever you want to somehow have some property about the abstract variable in a concrete model, you have to look at invariance where you actually try to link between the two states. So this particular invariance we said is called a linking invariance, which will try to connect the concrete variables, which will be A, B, and C here, and connect with N. So that will be the second equation that we can also try to derive. So 1 and 2, and also with number 3 here. So that is to say the traffic is guaranteed that C will be 0. So we try to combine 1, 2, and 3 all together. So that's how we eventually got A plus B should be less than D. That's a big picture, of course. And the detail will be combine these three equations together, you will be able to somehow cancel out C, for example, because C is equal to 0. And then we got A plus B less than D. That's what we get. Does it kind of help or still kind of lost somewhere?
I get like the steps, but for example, I don't know, like in another variation of another question, like I still don't know how to like correctly recognize.
Okay. So I would say this particular pattern, you can think about, you always start with the abstract version over here. So we start with this one here. So this N less than D. Okay, because you go back to the slide over here, it says that the number of cards in the bridge and the island should be limited. So as soon as you say that's limited, you can ask yourself, since we're dealing with a concrete model, is there a constraint that's already there that's constraining the abstract version of the model? Yes, we do. In that case, we just go back to the abstract version, and then we have this particular guard over here, N less than D. So whatever we come up with should be somehow more like a variation of this. But it's going to be expressed in terms of not N, because N is abstract. We want to express that in terms of A, B, and C, the concrete variables. So that's why we start with this one here. And then the way to really express N in terms of A, B, and C will be using the linking variance. So let's say if there's another variance for this particular guard, you will number one look for the abstract version, and then number two, you'll look for the relevant invariance that can connect the abstract and concrete variables. And number three will be if there's any other extra constraints that's either from the earlier guard over here, or maybe somewhere, maybe another invariance. That's something, of course, you're gonna find. And then if they can actually help you simplify all the equations together, so you can derive something that will be in terms of the concrete variables only. And then that's how you derive it.
I see now.
Good. Yeah, there's indeed a pattern here. So start with the abstract version, and then to see how you can rewrite that abstract version in terms of the concrete variables. To do that, you will just need to find all sorts of constraints. That's either from the invariance or the earlier guards to help you. Yeah, so that'll be the pattern. Good.
I get it. Thank you so much.
No problem. Okay. Okay, so Gurjap, you raise your hand. Go ahead.
Yeah, just a quick question. Could you go through question 9 of the written test?
Question 9, sure.
The practice question?
I can do. How about this? Let me put this on the stack, because I would like to see if your classmate got any questions related to the lecture. I'll answer them first, but you said question 9, right? I will put on my
9,
I'll put on my notes, and then as soon as we kind of finish the lecture related question, I'll definitely go back to question 9. How about that?
All right, thank you.
Yeah, give me one moment. I'll write it down on my notes. Question 9. Okay, give me one moment. Oh, sorry, I just need to find my notes here. Okay, there we go. Question 9. All right, guys. Any other questions related to lectures? I can answer them maybe first, and then I will definitely can go to the practice test if you want to. Okay, I'll pause for one moment. If you got any question related to lecture notes, I think we can maybe use the first part of the review session to answer them. Okay. Okay. If not yet, I can definitely go to the question 9, but we can go back to the lecture related question as well. All right, is this one here? Gurjap, is that a question? That's this one here, right?
Yeah.
Okay, so basically this one is just to kind of choose the rule that should be applied, right? To the different parts over here. That's what you got to do. So you can think about, we are basically doing like a proof. I would say for the written test, because it's primarily multiple choice question, so that's why we can have you drag and drop. But I would say in the exam, that's coming in December, so I may not actually have this format. In that case, I might start with maybe somewhere in the middle, or maybe start in the beginning and ask you to prove it. In that way, you have to choose a relevant kind of inference rule for you to go ahead. So is there a particular choice you have in question, or you want me to go over all of them?
I just want to go through all of them, maybe.
All of them?
Yeah.
Okay, if you really want to, that's fine. Okay. Okay, let's see this. One moment. There we go. It's easier for me to see this way. Okay, so let's now take a look. Okay. Of course, you got to make sure you're familiar with all the inference rule that's we have taught to you. So let's say for the first one. For the first one, if you compare, okay, how about this? Let me make some annotation as well, so that'll be easier for you to review. One moment. Okay. Okay, let's now take a look at this. All right, so let's see the first one. The first one here, you can see that we have the same go predicates over here, and also you can see this one is the same, so that one hasn't changed. And then you can see that this part over here is the same as this part. See, so the only thing that's really difference is that we have dropped these two hypotheses. So whenever you're dropping irrelevant hypothesis, that's usually the first step. So that's monotonicity, right? So that's the first step. Typically, that'll be the first one. Not necessarily always, but typically. And then you can see from here, we have some disjunctive hypothesis. So that's why we can apply one of the rule, which is ORL. So the L here is telling you you can, if you remember, the L here means to the left of the turnstile. So if you think about this one here, this is, you can write it in another way. So less than D, or n equals D, turnstile, n less than D, or n larger than 0. So you can see the disjunction is actually on the left hand side over here, right? So that's ORL. And then you can split the hypothesis into two. So you can see hypothesis number 1, hypothesis number 2. Right? You can see this is number 1, this is number 2. Right? You can split them into this one here and this one here. And then you have the same goal. So that is to say, in order to prove this, it would be sufficient to prove this one in isolation and this one in isolation. You got to prove them both. Okay? And then for this one here, we can choose. You can see we got a disjunctive goal over here rather than disjunctive hypothesis. We can choose to prove any one of them. If you prove the left hand side, it will be OR R1, which is this case. But if I choose to prove this one instead, it's going to be OR R2, right? But now you can see that we are really proving n less than D and n less than D. So that's the left hand side. So that's why here it should be OR R1. All right. And finally, you can see that we got the hypothesis actually appear as part of the goal. That one is going to match the hypothesis rule. So that's why we got this one here, right? So far we got 1, 2, 3, 4. And then we got n equals d. And since we got equality, we got two choices. You can either do EQLR from left to right or EQRL from right to left. So to see which one it has been, if you go RL, for example, if you go LR, in that case that'll be from left to right. That one there will be replacing every occurrence of the left, which is n, by d, which is the case because you can see we replace this occurrence over here by d, which is matching this d over here, and replacing this occurrence of n by d, which is matching this d over here. But it is also possible that we may also apply EQRL. So if you look at the lecture notes, we actually saw one of the example where we could go for another alternative branch. But in this case, it will be EQLR. And for the EQLR, typically after that, we can also drop the equality that we used. So that's why this one here, number 5, will be EQLR first. And once we have replaced everything here, and then we can drop this one second. So here, number 5 must be EQLR first. And then number 6 will be to drop the equality. And finally, you can see here, we got this one here. And then we can choose to only prove and d larger than 0. It's like choosing the right-hand side of the goal. In that case, we choose ORR2, which is here. All right. Does it make sense to you, or you think you want more details?
Yeah, that makes more sense.
So it makes sense to you? Okay, I just want to make sure.
Yeah.
Okay.
Yeah, sorry, yes.
Oh, hard job. Oh, okay. I see. Okay, I was wondering about. That's okay. I recognize your voice. Don't worry. Okay, if that makes sense to you, that's good. That's good. So what hard job? So what you want to make sure is, so you want to go over. Let me show you something. So for those of you who haven't seen that, I just want to show to you. If you go to the lecture sites, and then you will see that on the in addition to the lecture notes, which we have been posting. And also you can see the guide here, and there are some notes over here. So if you open up these two PDF documents, so these are the inference rules that we have covered so far. There will be another 2 coming, but that will be after written test number 2. But for now, these are the rules that you have to worry about for the coming test on Wednesday. And then I also summarize all the proofs that we did in the lecture. You can also go over the proofs yourself as well, right? These 2 documents, right?
Professor?
Yes, go ahead, Billy.
Will we be given the inference rules?
You will be given the inference rule, yes. So you can, I think similar to the practice question. So I think if there are any question that kind of require you to refer to the inference rule, I will give you a link where you could, if you click on the link, you will see all the inference rule that have been covered. Yes, you will be given.
And Professor, for the question that you were just discussing,
yeah.
When you apply ORR1,
ORR1, yes.
Yeah.
Mm-hmm.
So in that sense, you have to prove the left-hand side and the right-hand side of the of the OR situation, right?
Mm-hmm.
Like n less than d. But when we're proving the goal, when the OR is in the goal, so at that time we're not.
We are not. Okay, that's a good observation. Yes. So if you're seeing the disjunction over here as part of the hypothesis, that is to say, you want to be able to discharge the goal either when this is true and when this is true. You want to make sure that either hypothesis is strong enough to entail the goal. So that's why you got to prove both of them. On the other hand, if the goal itself is this disjunction, it's a completely different situation. This is to say, I want either this one to be provable or this one to be provable. So if either one of them is provable, it will be acceptable. So that's why I can choose one of them. So whenever you see disjunction, that's either in the hypothesis or in the goal, the rule to apply will be different. You got to watch out that.
Okay, thank you.
Yeah, good. Okay. All right, guys, think about the questions. I'm still here. So think about your question. Yeah. All right, let me see. Okay, so okay, let me see. So Emra actually asked a question on the chat. So okay, I would say, let's say for this particular question here that I just spoke about, let's say it's a multiple choice. If I only put like a single label over here, that means only a single inference rule to choose. And then if I put two in sequence, that means applying this one first and then by this one. Of course, you know, in the written test, if you got the multiple choice format, then this will be pretty obvious. Like you can only choose a single one for each label. Okay, but I would say for the exam, which we can speak a little bit more about maybe later, but briefly speaking, in the exam, I might only give you this sequence to start with, for example, and then you gotta show the rest of the work. Then the principle will be you should only show usually only one inference rule at a time, just to make sure every step is as small as possible. There will be some exceptions. One of the very few exceptions is whenever you're applying, let's say EQLR over here, EQLR or EQRL, if you apply the equality rule. So after doing the substitution, as I mentioned earlier in the review session or in the lecture, so whenever after you apply this one here, typically you will just drop the equality as irrelevant. So that's why we can save you some writing usually in the exam. By allowing that, you can actually say the EQLR followed by monotonicity just by dropping this one. Okay, but if you want to drop more hypothesis, in that way you will need to have another MON, you know, to really show what hypothesis you have dropped. So I would say this is one of the very few exceptions. I'll talk a little bit more about this maybe when we get to the exam, getting closer, and we can talk about the requirements. But I would say in the actual test, if I actually put labels like this, you can assume that each label corresponds to only a single inference rule. Okay. So Amram, I hope that answers your question. I hope. Okay.
Professor, could you go over question 1 of the practice test?
Question 1, sure. But guys, at the same time, if you got any question related to lecture, just speak up anytime. Otherwise, I can go over some practice question at the same time. Okay, good. All right. So this one here. Okay, sure. Let's go over them. Yeah, absolutely.
Because when I was trying to prove it, so I used monotonicity in the
Yeah.
first one. Then I used P3, then I used ORL, and then I used P2 prime. Because like what I did was like I used monotonicity to just have n is natural numbers, which is proving n minus 1.
Yeah, give me just one moment. Let me now put this one here on the sheets, and then we can talk about it. Just give me one moment. Yeah, there we go. Okay, let me see. Yep. So Billy, can you say it again? What did you apply?
So first was monotonicity. So
okay. So if you do monotonicity, so what did you drop?
So I dropped D and n less than D. So I only have n belongs to natural numbers in that opposite.
Sure. Okay, let's say you have that. Am I correct? That's what you have?
Yes.
Okay, very good. And then?
So I said that n belongs to natural number using P3. It means that n is greater than equal to 0.
Sure. Okay. Okay, go ahead. Yeah.
And then after P3, so that n greater than equal to 0 using basic arithmetic, you can say that it's n greater than 0 or n equals 0.
Not quite, actually. So Billy, I can tell you that. So when you said you apply P3, am I right?
Yes.
Okay, we'll get to P3. So you said that you apply P3 and then you got n larger than or equal to 0.
Yes.
And then you have this. Okay, first of all, let's discuss this particular step. Okay, just this step specifically. This step here is actually not right. I can tell you why. So if you go to the rule over here, for example, okay, let's go there. So you can see that P3 over here. Okay, let me just copy this one here and then I'll put it in the context so it's easier for later review. Okay, so I'll put it here. Okay, P3 is over here. Okay. Now, first of all, when I agree with you. If I say n is a natural number, then n is larger than or equal to 0. That one I agree. However, you cannot say that you go from here to here by using P3. You cannot say that. Because P3 tells you that if you have a turnstile where you actually have n is a natural number on the left, and also n larger than or equal to 0 on the right, which is not the case. But if that was the case, you can conclude that it's proved. But it's not the case over here. So applying P3 over here is not correct.
Okay, so we can use arithmetic to.
Okay, yeah.
See.
Okay, sure. Okay, so first of all, when you say you go from here to here, you cannot say it's by P3. You cannot say that, okay? But let's say if you say arithmetic, okay, let's say that. If you say arithmetic, so n is a natural number, and then you say n is larger than or equal to 0, that one I'm okay. That one is fine, okay? And then what else?
So that basically means that n is greater than 0 or n is 0. Again, using basic arithmetic or something. Like when we say that.
Okay, sure. So okay, so if you want to, so if I understood you correctly, you want to say by some arithmetic over here again. So this guy here is n larger than 0 or n equals 0.
Exactly.
I agree.
Oh, okay. I understand what it is.
Okay, this one actually is not going to lead you any further, because over here, this disjunction here is in the goal. Sorry, in the hypothesis. If you somehow want to split that into two, that means you can do the ORL rule, and then you say n larger than 0, and then you want to say n minus 1 is a natural number. This one is fine. However, if you do the other one, n equals 0, and then n minus 1 is a natural number over here, this one is not good. Because when n is equal to 0, how can that minus 1 will still be a natural number? So you're going to kind of get stuck over here.
I thought that I can only prove one part of the hypothesis to prove the rule.
No, you cannot actually. So just remember, when you have, okay, again, I think that kind of go back to the earlier question I kind of asked me. So if you got a disjunction in the hypothesis, that means we can split into two sequence, and then with the hypothesis go to each one of the sequence here. However, you must prove both of them in order to prove the original one. On the other hand, if you got the disjunction in the goal here instead, in that way you can choose either one to prove. So they're different.
Thank you.
Okay, good. Alrighty. Okay, let me just go back here. Okay, good. All right, guys, any other questions? Yeah, I would say maybe I think the best way to also get prepared will be if you can go over the longer proofs that we also went over in the class. And I think one of them, for some of them, I also gave you as exercise, but you can also find the solution on the slides. And of course, usually when I set up the class example, I kind of told you what the relevant inference rules are for you to complete the proof. When you practice, you may just want to kind of hide them. You just want to get a sequence to be proved. For example, I'll give you one example here. So when you try to practice, let me see. Let me show you one example here. And then, meanwhile, if you got any question, just let me know. Okay. Let me see this one here. Okay. Bear with me. Should be here. Yeah. For example, let's say when you practice, you may just want to take a sequence just like this, right? Take it and then get a piece of paper with all the inference rule. You can just go to the rules PDF I kind of show you on the lecture site and have the rules aside and try to start with this and see how we can prove them. All right. Rather than going to the iPad notes, in which case I kind of gave to you the relevant inference rule to really start with. You don't want to be too spoiled by that. You want to really see which rules to use. All right. All right. All right, any other questions?
Professor,
Yeah.
regarding question 13 for the practice exam.
Question 13. Yeah, go ahead. Yes.
So I put that D is equal to 5 is also a valid init statement. Can you explain why that is not the case?
Okay, sure. Okay, say we are now define the actions of special. Okay, initialization, and then in choose that may be used as an action of init. Okay. Right. I got it. Okay. So here, this one for sure. Oh, you're asking why this one is not included, right?
Yes, Prof.
Oh, that's because D is a constant. You cannot change a constant.
Oh.
Right? So remember, init can only initialize the variables. It cannot initialize the constants. So A should not be chosen because you cannot initialize a constant. Constant always has a fixed value, right?
Okay.
And then this one here is okay. You basically say, I want to initialize n. On the right hand side, it will be the constant value, which is already fixed, minus 1. That one's okay. And initializing variable to be a constant value, like a concrete value, that's okay. And this one is not good because there's no pre-states for initialization, so it cannot refer to any variable here. And this one here, just watch out, is equals rather than calling equal. So that's why that's also not good.
But it's in the answer, right? So, I mean, it's wrong.
That's in the answer?
I mean to say, like, in the correct answer, that's one of the options.
Wow,
So
apparently that should not be in the answer unless I make a typo. Okay, so here, okay, no, I can, I'll try to make a clarification over there, but I'll make sure I double check the actual test question. Maybe this one here was a typo. So this one here, I would say that should not be there. Okay, I can clarify that. So for question 13, for this option here, if you only say n equals 10, that should not be chosen. So I think maybe I just made a typo. Maybe I really meant to say n colon equal 10. That may be. Okay?
Yes.
Yeah. I'll see if I can change the answer in the practice question. If I cannot, because the quiz has been started. If I cannot, I can make a short announcement to clarify that. Okay, question 13. Yeah. Okay, good. Yeah.
So, do you think you can explain guard strengthening, which was in question 15 as well?
Question 15?
Yeah, it was 15, but I was just having trouble understanding the concept behind it as well.
Mm-hmm. Right. So this one here, so if you we talk about guard strengthening, so it's really about the concrete guards should really imply the abstract guard. So I would suggest, okay, so let me I'll talk about the question itself in just a moment. But at the same time, you will want to take a look at maybe here. Yeah. So I think one of the pages over here kind of explain why it will have to be concrete implies abstract as opposed to abstract implies concrete. So I would suggest maybe review that page as well. But I'll go back to that question, but I'll just show you which page you should look at. Yeah, so this one here. So you want to maybe review about why it should be abstract. When we say abstract implies concrete, why it is not valid, right? We talk about the principle that the refinement should not really create any new behavior, right? That's the principle. You want to review those points. Okay, so this one, and just remember, for when we talk about guard strengthening, we are only talking about the abstract versus concrete events. Especially if you, let me just give you another reference over here. Give me one moment. Yeah. So if you also go to the lecture notes from last Thursday, remember I actually talk about the categories of events, which will be here. Okay, I'll show it to you. So just loading a bit slowly. Okay, it's coming. Yeah, there we go. So you can think about whenever we have a refinement model like M1, so for every corresponding abstract events, we have the concrete events, like MLL abstract, we got MLL concrete. We got MLN abstract, we also got MLN concrete. So whenever we talk about guard strengthening, we are only talking about the concrete events versus the abstract events. Because when we talk about new event, there's no strengthening over here, because there's really no like a specific event that is really corresponding to. So we are really talking about the disjunction of, we are really talking about the guard that's in a concrete event, for example, MLN, really imply the guard for the abstract counterpart, which is MLN over here. So that's a proof obligation. And if you go back to the question itself, so the proof about the guard strengthening in refinements, the guards of all the concrete events, this is not right. Because we talk about individual concrete events, we don't really try to disjoin all the guards together. We don't do that. Right? It's only a specific concrete events that we are talking about. So the guards for the concrete event should imply the guard for the abstract events. That would be the definition for guard strengthening. Right, good. But on the other hand, if you talk about like a disjunction of the guards for all the events, that's to do with the deadlock freedom, right? I can kind of review the idea about deadlock freedom, okay? So just notice that we talk about the two opposing ideas. So one is about deadlock freedom, the other one is about deadlock, right? So they are the logical negation of each other. So you want to be sure about which one is which when you review the lecture notes. Okay. All right, guys, anything else? All right, if not many, maybe you guys can spend more time, going over the material. You guys still have until from now until Wednesday. So definitely go over all the cover materials, and then I think the practice question can tell you the formats of the question. They will be true and false. They will be like a drag and drop, the inference rule for the proofs, and there might be other things too, right? So I think the safest bet would be to go over the lecture notes and also the example that we discussed in the class. There should be no surprise about the actual test. Okay, I'll pause for one more moment to see if you guys got any other questions. Yeah, meanwhile, I see no updates on the chat, so no new questions. All right, if nothing else, should we end the review session earlier? And then you guys can maybe take some time to review more, and then come to me, office hour tomorrow, or maybe on Tuesday. All right, I'll be there. If you still have questions, feel free to ask. That's okay. If no, we can end here. All right, let's call it a day then. All right, guys, take care, and then I'll see you maybe during the office hour. If not, maybe on Tuesday. We'll continue to discuss the bridge controller. All right, have a good night. I'll talk to you later. Bye-bye. Bye-bye.